Hey guys, it's Nick from WGuru.com. Today I'm going to introduce Ohm's Law. So Ohm's Law states that current is directly proportional to voltage and inversely proportional to resistance. Now I kind of like to write it like this better. This makes our algebra a little bit easier to work with later because we don't have to worry about this fraction here. We could just move stuff over if we need to. So what does this mean? Let's talk about this. Let's go back to our water analogy. Okay, so here we've got our water circuit again. Our little pump is right here. This is the water wheel. We're going to use this as resistance. So if this water wheel is a little bit more difficult to turn, then the resistance will be higher. If the water wheel is a little lighter, then it will be easier to turn. This guy right here is just going to tell us how much current is going to flow through that piece of pipe. So again, we've got water flowing in here and then coming back down. Okay, so Ohm's Law is a relationship between the current, voltage, and resistance. So what it says really is if we have any two of these values, we can find the third one. So if we have voltage and current, we can solve for R. If we have resistance and current, we can solve for voltage, and so on. So if we have the force that's put in by this pump right here, and we know how much resistance is in this water wheel, we should be able to figure out where this little needle is pointing. In the same way, if you knew the resistance of the paddle wheel, and you knew the current flowing through this pipe, you should be able to figure out how much force this pump is exerting on the system. So let's do a thought experiment. Let's say that our pump is set to a certain pressure. We can't change that. But we increase the resistance of this water wheel right here. What's going to happen? So it's more difficult for the water to flow through here. You would think that the current in the entire circuit would go down. And that would be exactly what would happen with this relationship. And the same thing, if you increased the pressure here and left the resistance the same, the current will go up. And that's exactly what Ohm's Law says. If we increase the voltage, then our current goes up. If we increase the resistance, our current goes down. And that's exactly what we thought about right here. That's exactly what we got from the thought experiment. So let's do some electrical examples. So let's say we've got this circuit right here, and we've got 5 volts here, 5 ohms on this resistor. How do we solve for current? So the only thing we have to do is plug in this equation up top. We don't even have to rearrange it. We plug in 5 volts and 5 ohms, and we get 1 amp. So let's try another example. So let's say we don't know our voltage source this time. How do we solve for our voltage source? Let's start with our original equation, and we can rearrange this equation and then just plug it in. And we get 25 volts. Pretty easy, right? So we have one more example. So how do we solve for resistance using Ohm's Law? Well, we start with our original equation, and now we need to solve for R. Now all we have to do is plug it in. So this is your takeaway, guys. Remember this one, and really sit and think about this for a little bit. Think about the water analogy. If you get a really intuitive understanding of what's going on here, it'll help you a lot. So we'll see you next time, guys. Good luck.